right, y'all. So we're about to start another section of our notes here. So we're going to talk about naming polyatomic ions. We kind of briefly mentioned them in our warm-up on Friday, but this is going to delve us in deep. So polyatomic ions are positively or negatively charged, covalently bonded groups of atoms. Common ones to know, and these definitely are important, so I'd make sure in your notes that you have these like highlighted or something like that on top of what you already have to add about them. So some common ones to know are ammonium, which is NH4 with a +1 charge, nitrate, which is NO3 with a -1, hydroxide, which is OH with a -1, phosphate, which is PO4 with a -3, and then sulfate, SO4, which is a -2, carbonate, CO3, which is a -2, acetate, which is C2H3O2, which is a -1 charge, and then chlorate, which is ClO3. -1. This is again why I have you guys making sure you're doing your subscripts and your superscripts correctly, because this is where it may start to get confusing as well when we start balancing equations. So we're going to go over how to name compounds, ionic compounds, but we're going to add some exceptions because of polyatomic ions. So this should look familiar. You're going to write the name of the first element, which is the metal. If it's a polyatomic ion at first, you're just going to use a special name that were given previously. You're going to write the name of the second element, which is the nonmetal with an IDE ending. The exception to this with polyatomic ions is you're going to use the special name, no IDE ending. So some examples. This is sodium and phosphate, so sodium phosphate. This is magnesium and sulfate, so you're going to do magnesium sulfate. And this is ammonium and chlorine, so this is ammonium chloride. Okay, so you have examples here where the polyatomic ions are the second nonmetal, and then you also have it where they're considered the metal, so you keep the special name. Now let's go ahead and practice with exception number 1. So you're going to go ahead and write the names of these compounds based on the chemical formulas below. Make sure you pause, figure that out, and then I will give the answers momentarily. Okay, number 1 is sodium nitrate. Number 2 is calcium sulfate. Number 3 is ammonium oxide. Number 4 is magnesium phosphate. 5 is ammonium nitrate. So you can have this where you have 2 polyatomic ions like this. So you just use both their special names. Then how to determine the formula for an ionic compound with polyatomic ions. We're going back from the name to the formula. So you're going to write down the ions of each element with the charge. So the only difference is here is you're going to use the polyatomic ion in the parentheses. You're not taking it out. You're not separating it. So for example, let's do calcium phosphate. So you got calcium with the +2 charge, and then you got phosphate, which is a -3 charge. You're still going to cross and drop those charges, but you're keeping this polyatomic ion in their parentheses. You're going to determine the number of each ion it takes to make a compound with no charge. So you're going to crisscross applesauce. You're going to keep the subscripts outside of those parentheses, and you're not going to change anything on the inside. You don't touch it. So again, you're going to cross and drop that charge, cross and drop that charge. So you're going to write down the formula using subscripts to show how many of each ion it took. And you should get this for calcium phosphate. So you'll notice that the phosphate was not changed. We kept in the parentheses, and we have kept our subscripts on either side or on the outside of the parentheses. Oops. And then, of course, you can reduce and simplify if needed. So remember, you can only reduce and simplify if both subscripts here and here are the same. So let's go ahead and practice again, going from the name to the formula. Go ahead and pause, walk through these, and then I'll give you the answers. So for barium sulfate, this is what it should look like. Aluminum carbonate should look like this. Calcium nitrate should look like this. Sodium acetate should look like this. And potassium phosphate should look like this. So now we're going to go ahead and I'm going to have you turn these in, and then I will go ahead and we will do some more practice tomorrow with these particular ions. Let me know if you guys have any questions.